Hello guys, so now I'm gonna show you how to solve odd occurrence problem that sometimes comes up within interview questions. So what's the problem? I will copy and paste it. So the problem is you have an array of n integers. N is always so the array always contains an odd number of elements, and each element of the array can be paired with another element that has the same value, except for one element that is left unpaired. But you need to write an efficient element, assuming n can be up to 1 million. So in this guide I will mostly focus on generating that sample rather than actually finding the solution, because solution is very simple, as you will see at the end. So how do we, so let's say our n, what it will be, or our, let's say, solution, let's call it, let's say it's a number 100, and then let's generate two ranges. Let me show you what I mean. Enumerable dot range to 100, and let me show you what it does. This does the following. Range 1. Okay. Okay, I'm missing the comma. Okay, let me show you. Okay, so this generates 100 numbers from 0 to 100 with enumerable dot range. So if our solution is 100, what we need is we just need to double the range, right? So we need 0 to 99, 0 to 99 two times, and the solution can be 100 then. And let's make it like this. Okay, you can maybe already assume where I'm going with this. So what if we concat the range 1 with range 2? Well, we get the numbers from 0 to 99, somewhere right here, and then from 0 to 99 again. So all of these are paired, and so what we got here, we actually generated something of sample where we have 100 numbers that are already paired, and our solution can be this number. So, but we don't like this ordered collection, so someone could cheat and easily find the solution in that case. So var, let's call it our collection equals range 1 dot concat range 2. Okay, to list. Okay, yeah, and that collection needs to have the solution in itself as well. Let's string that join again, show you the collection now. As you can see, everything's the same except we have the solution in here as well. So, but it's ordered, so we already know where the solution is. And what I want to do now is I want to actually shuffle this list so that the numbers are randomly organized. For that I will make an extension method so that we can call it on our list and shuffle it up. Okay, so tools, extensions, public static class, and let's say, okay, so let's Google it simply. So C# shuffle algorithm. As you can see, I already did this. So the algorithm that I like is this Fisher-Yates shuffle algorithm, and the person here already wrote it as an extension method, so we can just copy paste their code and test it out and see. So let's make it so that it's in our own number generator. Let's make it look like it's ours. List is usually source, that's how we call it in our tutorials. This can be also read-only, and we can use tuple, yeah, to swap out these values. And now this looks pretty cool. And one more thing, maybe we could place this here instead of down there. We'll see. Anyways, let's now shuffle the collection. Okay, we need to be using our tools. Odd occurrence tools. Okay. Collection.shuffle, and let's print it out shuffled. Let's see. Okay. Void to object shuffle is a void. Okay. So it actually shuffles the list, doesn't return it. Let's return it. Let's just return the shuffled list. Turn back the source. Sorry. Okay, let's test it out now. And as you can see, it's shuffled pretty well now. Now we know the solution will always be 100 or something that we set here, but we don't know where it's gonna be. Or we can set it like 69, and it's somewhere in here with all the double values. And we can assume the highest number will be 1 million, so this can be 500,000. Okay, so you know it can be a pretty large list, and we need to write an efficient algorithm for that. But let's make it 1,000,000 even. I think our algorithm will still work pretty well. Okay, so what I don't like here is, so let's call this sample or input to our algorithm. And let's make it like it's a one query. So let's add an extension method for adding items. Public static t add item, but let's return the list. This I list of t source. Let's just source that add. We are missing item, t item, and return the source. With that we can also, instead of adding the solution there, we can do add item, and this item we are adding is solution. So we are concatenating these two ranges of same numbers with the solution, which is different always than these numbers, because it's always lower, higher by 1 than all of these. Okay, and let's print out our input. Let's go over something smaller for now. Okay, so the 100 is here, but it's not shuffled. Okay, so we are missing that shuffle. Okay, and now we could try and find 100 somewhere by ourselves, but This is the part where we need the algorithm. And let's make the algorithm as an extension, the solution to this problem as an extension method as well. Why not? Because okay, let's do some console write lines. Expected solution is, and let's put solution there, and our result is result. Okay, so how do we find the odd occurrences? So it needs to be that the item find or occurrence on this I list of item T So how do we find it? How do we find the odd occurrence in a list? So this is the easy part. Well, you could use a dictionary, and like when you add a new item to the dictionary, you count the amount of times it's inserted, and every number will have its value 2, except for the solution, which will have a number 1 to it, because it appeared 2 times. But instead of that, what if we just did this? Just use a hash set and iterate over the, okay, for each item in source. What if we add it to the hash set? So it's like adding to the dictionary. It's a fun operation, so a super fast operation. And what does the add say? It returns true if the element is added to the hash set, false if the element is already present. So let's think about this. What if we just keep on adding items here? So for those that will repeat itself when they are added, first time this will be true, and the second time it will be false. But this will be only true once for the item that we are looking for. So my idea is, if this is false, we know that the item in question is no longer important to us. We can just remove it. We can just remove the item. And what will happen for that one item that is single, that's not repeated, he will be the only one left in this set, and this is the solution. It is as simple as this. Okay, so let's try it out. So our input dot find odd occurrence should give us now the proper result. Okay, we send the list. Let's console write line. Let's prove it to ourselves that this is actually working. Let's put some random number like 74 items in, times 2 plus the one that is 74 that we are looking for. Let's write something out like sample input is, and then console write line string dot join. Something's wrong here. Oh, okay. String dot join, and let's join by the places are input. Okay, you can see the input is shuffled properly. Expected solution is 74 and our result is 74. And you can try to find it here, it's somewhere in here, but you know. And let's see if our algorithm is efficient. So it needs to work well for 1 million, which is actually half of that, since we have these two ranges. But let's make it a 1 million, so it will be 2 million. 1, 2, 3, 1, 2, 3, yeah, 1 million. Okay, let's not write this out anymore. Bam, solution is here. So let's see if it's actually good enough. Usually how you test that out is by measuring the time with the stopwatch. Sorry for the birds. So our stopwatch equals stopwatch dot start new. Okay, and let's measure stop. Let's measure how long it took to generate the sample. Let's say by seconds. Okay, it will be stopwatch dot elapsed dot total seconds, right? And let's see how long our solution took. Stopwatch dot restart and stopwatch dot stop. Generate a sample, calculated result in seconds. Let's see. Okay, so generate the samples in 0.09 seconds, calculated result in 0.29 seconds, express the solution. Nice, nice. Let's put something like 950,000, 9, something random. Yeah, it still works properly, and that's it. That's basically it. So if it's under a second, it's considered to be efficient usually. I think that's what considered to be efficient. So the only part that we didn't do, we actually just copied out this part from the internet, but everything else is super easy. Anyways, thank you guys for watching and see you next time. Bye bye.